These features that we are going to cover today are common to all our products, whether you're running our flagship standalone visual CAD/CAM, or you could be running our plugin for Rhino, which could be Rhino Cam, or your plugin for SolidWorks, our visual cam for SolidWorks, or even if you're running a Libre Cam, the workflow and these steps are going to be exactly the same. So first, I'm going to be starting out with our visual CAD/CAM application, and we'll go through the process of how we could create standard tool types and setting the tool properties. I hope everybody is able to view the screen. If you're having trouble, please go ahead and click on the raise hand button so we can make sure that there aren't any technical issues and you're able to see it. Now, as you load the application, there is two halves to the browser. You have your machining operations browser, or the machining browser, which typically appears on the top half, and then the browser window, which is called the machining objects browser, which appears by default on the lower half, or you could have it docked over on the side of your machining browser itself. So the Tools tab can be located under the machining objects browser. Now, if for any reason you're unable to view the Tools tab or the machining objects browser, you would need to select the toggle Tools Machining Objects icon, which is found just to the left of the Program tab in your machining browser. So when you click on Tools and Machining Objects, this will display the Machining Objects browser right below the machining browser, or if you had it docked over to the side, it'll appear right next to it. Now, this is how it'll work in Visual CAD/CAM and Rhino Cam. If you're running Visual Cam for SolidWorks or Libre Cam, you will see the Machining Objects browser docked or appearing below the machining browser. So once you have the machining objects browser visible, you will notice that the Tools tab is the very first tab that appears down under the machining objects browser. Now, under the Tools tab, you have different controls in here, and during the webinar we'll cover each of these. The first thing I'm going to go over is creating tools. So as you select Create Edit Tools, this brings up your Create Edit Tools dialog, and it lists all the different tool types that are available to you. Now, the tool types that you're seeing here are available in all of our configurations starting with standard. So if you're running standard, expert, pro, or premium configuration, you will have access to all of these tool types. And as you hover your cursor over these tool types, you'll see that the tool tips would appear representing each of the tool types. So we have tools of type ball and mills, flat and mills, corner radius tools, tools for engraving, chamfer, taper tool, thread mill, face mill tools, dovetails, fillet mills, lollipop cutters. We have user-defined tools, which we're going to be covering as well. And then we have drill, center drill, reamer, tap, bore, and reverse bore. Now, you could define tools under each of these tool types. So, for example, let's consider a flat mill. So for parts that you would be using 2.5 or 2-axis programming that are mostly prismatic parts like the one that we have showing up on the screen here, you would be wanting to use typically a flat mill for a facing or a pocket or a profile operation. So you could define tools in here. So we would pick a tool type first, and then you would specify a name for the tool. You would want to specify a tool name that's easy for you to locate and access them. So typically I would call it flat mill, and I would put in the diameter to identify the name, specify a tool name, specify the tool diameter in here, and then also specify the properties of the tool, like the flute length, the shoulder length, the tool length. Now, as you specify these properties in here, you could either enter in the values or use the spinner increment to specify it. You'll notice that the preview of the tool is also automatically being updated in here. As you make changes to the tool, you will notice that the tool preview automatically updates. So you can specify the parameters for your tool length, shoulder length, flute length, your shank diameter, holder diameter, and the holder length can go right in here. So once you have these parameters defined, you then want to go over to the Properties tab over here on the right side, where you can specify the material for the tool. You could be setting it to carbide, high-speed steel, or ceramic. So once you specify the material type, you could also assign a color for the tool material. This is something that's new in version 17. This can be used for cut material simulation. So you can assign colors for cut material simulation based on the tool. So you can have a color set for each tool that you're working with. So you could specify that, and then you could set the number of flutes. It could be a 2, 3, 4, the number of flutes for the tool. And the most important parameters are your tool numbers, your adjust register, and CAMJam register. Now the tool number, if you're working with a machine tool that has an automatic tool changer, you would want to make sure that you set the tool number according to what's on the machine in your, for your tool change. If the half-an-inch end mill is on tool 1, you would want to make sure that you put the tool number as 1 in here as well. Now the adjust register, defines your tool height offset register. Typically in the posted output file, this is output as a G43H and then a value, and this basically points to your tool table to obtain the height offset. And in most cases, you would set the adjust register number to be the same as your tool number. So you would want to make sure that you set the tool number and then your tool adjust register, which is basically the height offset register. And then if you're using curve compensation, like a G41 to compensate left or G42 to compensate right, some controllers expect you to also output a CAMJam register like a D followed by the register number. And in most cases, you would also be setting this to be the same number as the tool number because it points to the table for the CAMJam register, and the value that you're going to be compensating is what you would enter in the controller's tool table for the CAMJam. So basically this maps to the tool table's registers. So you would want to specify these. Now one of the nice things what we do in our CAM system is we automatically set these adjust and the CAMJam registers to the same as your tool number, so just to make it easier for you. So if you leave these as 0, then you wouldn't be applying any offsets for your height offset or CAMJam register. So we automatically make sure that your adjust and the CAMJam registers are set to the same as your tool number. But you do have the ability to go back and override it and make changes to it. Now finally you have what's called the axial offset. Now this is this value can be set if you'd like to offset the tool path axially, meaning if you're doing a 2 or a 3 axis operation, an axial offset would be an offset in the z-axis. So by specifying a positive value for the axial offset, this would offset your tool path, the program tool path in the z-axis by the specified value. If you put in a negative offset, the tool path would be dropping further down in the z by the specified value. By default, this value is set to 0, and if you specify a value for the axial offset, this would apply for all the operations that you program with this specific tool, and you will be able to notice the toolpath being offset in the toolpath preview once you have the toolpath generated. Typically this would be set to 0. You could use the axial offset if you need to offset it. Now the next thing is your coolant. You have the coolant choices in here. You can specify the coolant type. You could set the coolant, by default it's set to none, or you could set it to flood, mist, or through. And the coolant codes, the M codes for coolant, can be defined in your post processor, whether they're M8, M7, whatever that needs to be based on the coolant type. Those can be defined in your post processor. Now you also have a section in here where you can enter in comments for your tool. The comments can be a single line comment, or it could be even using a multi-line comment where these can be specified. Now for example, if you want to output the tool name or the also the SKU number from where you source these tools, so that if you have multiple end mills of the same size but you want to use a specific tool from a specific manufacturer, you can enter in those comments, and those comments can also be output in the posted code at the start of the operation. So you could specify a comment. The comments could be a single line comment, or you could have a multi-line comment as well. There's also one nice feature in this comment section. Typically the comments are output in the posted code with the comment start and end character, but if you want the comment to be output as a line of code without the comment start and end characters, you could output by adding a prefix $sign as a prefix, and you can specify the comment to be output. For example, if I need to output an optional stop in here, I can put in a dollar and then an M00 or an M01. So instead of outputting the comment with the comment start and end characters, it'll be just outputting as a normal regular line of G code in here. So you can specify it with a dollar as a prefix sign, and you will find that the comment is not output with the comment start and end characters that you define in the post. So once you have the properties tab filled in here, the next step is to go into the feeds and speeds tab, where you can set the feeds and speeds, the spindle speed, the feed rates, the plunge, cut, engage, retract, departure feed rates, transfer feed rates. Now you could set these parameters, or you could use the load from file. So if you refer to the previous webinar that we had last month, you can learn more about how you can set feeds and speeds. We had a topic full of how to use the feeds and speeds and the properties on a separate webinar, so you can go back and visit that. So I'm not going to go ahead and cover the feeds and speeds topic in here in detail, but you can set the feeds and speeds for each tool that you're defining. And once you have these properties defined, you'd want to click on Save as New Tool. Now once you have a tool defined in here, if you'd like to make any changes or edits to it, you can go ahead and make those changes in here. So for example, I can modify my tool length. Once I make those changes, I would select Save Edits to Tool, so these edits would be updated on the particular tool. Now when you pick OK, this tool that you created is listed under the Tool tab in the Machining Objects browser. Now you can have one or more tool of each tool type defined in here, so you can go back and edit it. And if you'd like to add a new tool of the same tool type, you need to make sure that you have to specify a new name for the tool. You cannot have two tools with the same name assigned to it. So you need to specify a new name for the tool. As you can see, the Save as New Tool option is grayed out because I cannot define a second tool with the same name. So I'm going to go back in here and change the tool name to a 1/4 inch. And once I make a change, you'll see that the Save as New Tool option is now enabled. I can enter in the properties for the tool. Now with our 2017 version, you could also use fractions to enter in your tool properties. If you want to define a 1/4 inch end mill, I could say 1/4, and we can automatically compute that in decimal. You can do that for any of these fields in here. You can specify those properties. You can set you can update your comments as well. And as you notice here, once I select Save as New Tool, with leaving all the other parameters at the default settings, since I have not modified the tool number or the adjust, register, or cut com, when you select Save as New Tool, you're being prompted with this dialog saying tool number is repeated, and would you like to use a non-repeated tool number? So as you select yes, as I mentioned earlier, the tool number is automatically incremented by the next available number, and you'll also notice that your adjust register and the cut com register is also set to the same as your tool number. So that saves you the time to going back in here and editing and setting the adjust and the cut com registers in here. So once you have established the properties for the tool as well as your feeds and speeds in here, you could select Save as New Tool, which I just did. If you make a change, you would select Save Edits to Tool, and those edits are saved. And you'll now notice that we have two tools in here under the type flat mill. We have a 1/2 inch flat. We also have a 1/4 inch flat. Now as you select these tools that are appearing in session, you will notice that those tool types, the tool properties are displayed in the dialog. So selecting OK again will automatically display the tools that you just defined in here. Now you can create tools under each of these tool types. You can define tools of type ball mill, other types. So let me go ahead and add a ball mill tool in here. I'm going to specify a tool name, specify the properties for the tool, and you'll notice that the tool number, as you switch from one tool type to the next, it automatically assigns the next available tool number. So since we already have two tools defined in here, we have tool 1 and 2, it automatically sets the next number to 3. You pick Save as New Tool. Now if you want to add a new 1/4 inch ball mill, you'd want to go back in here again and change the name for the tool, specify the tool properties, And once I set the tool properties and I've changed the name, you'll see that the Save as New Tool option is now available. I'm going to pick Save as New Tool. And again, since the tool number is being repeated, I'm going to select Yes to use a non-repeated tool number. And you'll now notice that the tool numbers are numbered 1 through 4. So the first two tools are flat end mills, and tools 3 and 4 are ball mills. So once you have these tools defined in here, they appear under the tools in session. So these tools, what you've created in here, are now available for programming on this particular part that you have open in session. So you could basically go ahead and program your tool paths using these tools.